Okay, so we have a homework problem from section 3.3 that wants us to complete an addition table and then use that table to do some subtraction problems. Now, this is all base 6, right? So that means there is no 6. Anytime you get to 6, then you're going to have to move over to a new column that'll be your 6's. So when we add 0 plus 0 in the 0, 0 column, we definitely get 0. I don't know if I can write this small. There we go. 0 plus 1 gives me 1. 0 plus 2 gives me 2. 0 plus 3 gives me 3. I know this is old. 0 plus 4 is 4. And 0 plus 5 is 5. No issues there, because all of those values are below 6. Remember, we don't have a 6, so we have to move to the next column. So that's coming. Let's do the next row, which 1 plus 0 is 1, 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3 is 4, 1 plus 4 is 5. Now here's where the issue comes in. We know 1 plus 5 in the base 10 system is 6, but what that really means is we have 1 6 and 0 1s. Okay, so that's how that works. So 1 0 in base 6 means you have one value of 6 and then 0 1s. Now let's keep adding the 2 row here. 2 plus 0 is 2, 2 plus 1 is 3, 2 plus 2 is 4, 2 plus 3 is 5, 2 plus 4, and here we go again, is 6, just like it was here. That means we have 1 6 and 0 1s. 2 plus 5, we know that is 7 in base 10. But in base 6, that means it's 1 6 and then 1 1 left over. So 1 1, right? All right, 3 plus 0 is 3, 3 plus 1 is 4, 3 plus 2 is 5. Here we go. 3 plus 3 is not 6. We already know 6 is 1 0. We know 3 plus 4 is 7 in base 10, but that means 1 6 and 1 1. And then 3 plus 5 we know is 8 in base 10, but what that is really 1 6 and 2 1s. So anytime you see 1 2, that's not 12. That means it's a 1 6 and then 2 1s. Really, it means it's 1 6 to the first and 2 6 to the zeros, okay? 4 plus 0 is 4. 4 plus 1 is 5. Here we go. 4 plus 2 is 6, which doesn't really exist. That's 1 6 and 0 1s. 4 plus 3 is 7, which is 1 6 and 1 1. 4 plus 4 is 8, which is 1 6 and 2 1s. 4 plus 5. It'd be nice if I didn't even think in terms of base 10, but I'm probably like you. I just kind of have to. 4 plus 5, if I build a 6 from there, that gives me one of those, and what's left over when I take 2 of these 5s to make a 6, that's going to give me 3. And notice they're steadily increasing. 5 plus 0 is 5. 5 plus 1 is 6, which is a 1 0. 5 plus 2 is 7, which is a 1 1. 5 plus 3 8, which is a 1 2. 5 plus 4. All right, if I take one of those 4s and add it to the 5, that's my 6. And then there's 3 left over. Okay, and then 5 plus 5. So I take one of those 5s, I add it to this 5, that makes a 6, and then there's 4 left over. So that's the table completed. Now, we're supposed to use that table to do these 2 subtraction problems. So let's see if we can pull that off. Addition and subtraction can get really confusing. Subtraction to me especially. So we have 3, 2, 4. Of course, that's base 6. Minus 2, 3, 5, which is also base 6. And they would have to be both base 6 to be able to add or subtract them. All right, now you see the first issue. We're going to start in the 1s column so we can exchange if we need to. We used to call that borrow. Now we call it like trade in or exchange. So here we go. Subtract 5 from 4. I can't, right? So I'm going to borrow one of my 6s. There's 2 6s here. I'm going to borrow one of them. So now there's 1 6 left over. And this 4 is now a 1 4. Now that's not 14. I'm not doing 14 minus 5 is 9. That's 14, just to remind you, base 6. Now, how do I use the table to do subtraction? So what we need to do is we need to find 14 right here inside the table. Okay, now there's only one 14, okay? But if there were multiple 14s, we would need to find 14 inside the table that's in this row. So our 14 is in row 5. Well, what column is it in? 5. That means that is 5. Okay, it's not because 14 minus 5 is 5. We know it's not. It's 9. But in base 6, it is 5. So what did I do? I went inside the table to find the minuend. Remember that word? So this is the minuend, and the 5 is the subtrahend, the thing we're subtracting. So you go inside to find the minuend. There's 14, and then you go to the row to find the subtrahend. It's 5, and notice that is in which column? And that's where I'm getting that from. Now, why did I go to the row here and not the column? Just because I did. You could switch that around and you would be okay too. Let's try this again, right? Okay, so right now, my minuend is 1, subtract 3. I can't do that. So I'm going to borrow again. So I'm going to borrow one of these 3s. Now, this is really 3 times 6 to the 2nd power, but we're not going to stress on that. We're just going to call that a 2, and I'm going to move that 1 over here. So now this is 1, 1. Okay, now 1, 1 is not 11. 1, 1 is base 6. So I need to find 1, 1 in my table. But in which row? Row 3. So go to row 3. There's a 1, 1. Okay. And then what's my answer? It's 4 right up here at the top. So notice I'm row 3. That's my subtrahend over here. And 11 is in the column 4. So I know this is a 4. Not just trying to do this all different colors for you. I apologize. And then 2 minus 2 we know is 0. Now when you have a 0 on the left-hand side of your number, then you don't need that. So this is just 4, 5, base 6. All right, so let's try problem B. All right, so we have 5, 3, 4, base 6, and you know what? I'm not giving myself enough room to get this problem done, so let's try this again. A little bit more room there. 5, 3, 4, base 6, minus 2, 3, 5, also base 6. Once again, I can't subtract 5 from 4. So what am I going to do? I'm going to borrow. So I'm going to cross out this 4 and cross out that 2. That 3 now becomes a 2. So we're really borrowing 6. But 6 doesn't exist in base 6, so we're going to say that's a 1, and we already had a 4 there. So I need to find 1, 4 on my table. Remember, there's 1, 4 is only in one place, but what I'm doing is I'm looking for 1, 4 in the 5th row. So here's my 5th row. Here's my 1, 4. So the answer to that must be 5. You get the gist of it? Okay, I'm going to do some erasing here. Let's try this again. So I can't subtract 3 from 2. 2 is my minuend, 3 is my subtrahend. My subtrahend cannot be bigger than my minuend, which means I have to borrow. So I'm going to borrow one of these 6 to the seconds and make 4 of them. And then that's going to move to the next column and add an extra one there. So I'm not really doing 12 minus 3 is 9. We're not doing that. I'm looking for 12. Okay, there are several 12s. Remember, it has to be in the 3rd row. So 12 in the 3rd row. What column is that in? That's 5. So 12 minus 3 is 5. Okay. Finally, 4 minus 2, because we're not in it. It's not really 12. I really should read it as 1, 2, just like this is not 14. It's hard to get into that habit. So 4 minus 2 is 2. So the answer is this is 2, 5, 5, base 6. Now you could just change all this to, it didn't say to do it that way, but you could change all of this to base 10 and then change it back to base 6. That's no fun, but it is a way to check yourself. So how could I do that? So I would have 5 times 6 to the 2nd plus 3. I'm looking at 5, 3, 4, right? Times 6 to the 1st plus 4 times 6 to the 0 and get that number. Okay, I'm going to write on the other side over here, not the 4, 5. Okay. You already have the answer to that, so I'm going to get rid of the 4, 5. Matter of fact, I'm just going to move it. So this is 4, 5, base 6. That's the previous problem. Now we're checking this one in base 10, if it helps you feel better. Now, and I'm going to get an answer for that, but not yet. And then I'm going to subtract 2 times 6 squared plus 3 times 6 to the first plus 5 times 6 to the 0. And that's going to give me a number. So I went ahead and wrote my numbers down. 202, subtract 95. Remember, this is just base 10, is 107. Okay. Again, that's base 10. Now, is 2556 the same as 107? Well, we could check it out by saying 2 times, this is going to be 6 to the second, plus 5 times 6 to the first, plus 5 times 6 to the 0. If that's 107, we did everything right. If it's not, then we probably need to check our work, and it might be a lot to check. And thank goodness when I checked it, I did get 107. Okay, and again, that just makes me feel better because I know working with these crazy bases is not easy to do. So if you can change it to base 10 and do the work, then you really know that it's right. But I like this table. That helps this problem a lot, because if I didn't have this table in front of me, when on the first problem, when I had to do, 1, 4 base 6 minus 5, I'm not really clear what that is. I would have to change it to base 10 in my head to really pull that off. We know 1, 4 is 1, 6 plus a 4, which is 10. 10 minus 5 is 5. You see what I mean? And so the table helps a lot. I wouldn't attempt to do any addition and subtraction without some kind of table in front of me. That way I don't have to convert everything to base 10. I hope this helps. Hang in there.